Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at this first one using the geometric sequence. So building on the theory we just did, find Tn and T10 of the geometric sequence 1, a quarter, 16th, and 1 over 64. Okay, so we need two things for the Tn formula. So Tn is equal to a times r to the power of n minus 1. And of course, that's here in the log tables as well. Okay, so you don't have to learn it off by heart. And we also know that a is the first term. Okay, so that's easy enough to find. And we know we'll get our common ratio from putting two consecutive terms over each other, the second one over the first. Okay, so a is the first term, or is the common difference, which is T2 over T1, or of course it doesn't matter if you do T3 over T2. So it's a quarter over 1, which is a quarter. Okay, so let's fill them into our formula for Tn. So a times r to the power of n minus 1. So that works out at a quarter to the power of n minus 1. Okay, now watch the way I put a quarter into a bracket. And I'll tell you why mathematically. If I write it like this, that could look like it's just got the 1 to the power of n minus 1. Okay, and 1 to the power of anything is in fact 1. Okay, so that is mathematically could be a quarter. So it's a quarter to the power of n minus 1. Okay, so just a tiny little thing, but it's those tiny little things as you go up the ranks in maths that matter. Okay, now we could simplify this even further using the rules of indices. Do you see here down the very bottom? Okay, you can, when you have a fraction to a power, you can apply the power to both bits separately. Now, I believe this is a perfectly acceptable answer to give in an exam. Okay, but if you so wish, you can go as so far as to say that's the same as 1 to the power of n minus 1 over 4 to the power of n minus 1, which is of course equal to 1 over 4 to the power of n minus 1. If you remember your reciprocals from when we did the indices question, if something is under the line, you can bring it above the line by changing the sign of the power. Okay, so if I change the signs of these powers, I'll bring it above the line. Okay, so I could write this as 4 to the power of minus n plus 1. I just change the signs of the power and then just write that backwards, 1 minus n, just so that we don't have a minus number at the start in case you forget it. Okay, so that is also an acceptable answer for Tn. Tn is equal to 4 to the power of 1 minus n. Okay, so why do we bother getting a Tn formula? Well, we do that so then it allows us to, it's a formula to calculate any term. And so that's why they asked us to calculate Tn, so that we could use our formula. Okay, so of course I can fill it into, I'm going to fill it into this one first, a quarter to the power of Tn minus 1, so a quarter to the power of 9, which is equal to 1 over 262,144. Okay, or of course you could use this formula. This is this one. You could do 4 to the power of 1 minus 10, and I'm presuming I didn't check that one, 4 to the power of 1 minus 10, so 4 to the power of minus 9, and yes, as I'd expect, it's equal to 262,144. Okay, so either way, I'm just taking the opportunity to revise a little bit of indices when I'm showing you this way. Okay, or of course a question could be, show that Tn can be written as 4 to the power of 1 minus n. Okay. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.